This is the first video for the 4100 board in an effort to show Brandon at North Texas Calibration how the 4100 boards. So what we're going to do is we're going to power with the board powering the primary of the transformer. Go ahead, Tony. And then what we have here is two test points. We have our reference, which is TP6. My reference is TP6, and then we have our delay angle TP4. They are square wave signals. One is at a 50% 60 Hertz, and the other one will determine the delay angle, and we'll look at the duty cycle. And we also are looking across the four outputs. The easiest way that you should be able to do this is by just take an oscilloscope probe and then just go between one of your probe at the gate and your ground to the cathode. So what we have here is we have a green LED, we have a red LED because the board's inhibited, and right now we have the potentiometers at 100%. Now the board is already enabled, right, Tony? You have enabled, and this is not a problem. So the board's inhibited because we don't have at least half a volt of sig high. Notice the VR CL1P is out, but we have to have that jumper between 3 and 4, and we're not bringing any feedback. We just want to make sure that the board is firing. So let's go ahead and we have 100% on the span and the bias. So this is the most simple way of firing. So we see that now we are, let's go back really quick, Tony. We're at the 0.6, we cleared the LED, but we're going to go back here. So let's see what happens here. The red LED, it's red. We have a 0.5 volts. Let's take a look at this here. So go ahead and do it, Tony. There you go. Right when he cleared, Tony, we cleared the LED at the 0.6. This right here, the duty cycle has decreased on TP4, and we have the corresponding output. Alright, Tony, you want to go ahead and do a sweep, go back to 0.5 again. That extinguished. You notice it extinguished, it went on again. The LED it's on. Let's go ahead and bring it on. Boom, there it is. Alright, and let's go ahead and keep on increasing now, Tony, all the way to the maximum. Don't worry about the span and the bias. And there it is, you have an output. Now, this box allows us to check all four outputs. So what we're going to do is we're going to go here. There's one. You notice that, bring it closer, bring it in a little bit, Tony. You notice there that this is actually the opposite of this is when the duty cycle here is low, that this is high. There's one. There's another one. 1, 2, 1, 2, 3. Oh, we probably have another.
Skips 3.
No, it skips 3, so.
Oh, okay, there you go. 4 and 5. There you go.
Oh, that's about.
Okay, you're right, because that's all right. So we have 1, 2, 3, 4, and 5. Perfect. And that's it. You have an output there, and this is what we're trying to do. What we need you to do, Brandon, is you can check for voltages. You've already done that, but the minute that you inhibit having the span and bias at 100%, without looking at any more test points here, what you can probably do is disconnect here. Help me out. Disconnect this, Tony. No.
Okay. Oh, that's a power.
Oop, that's my power. Go ahead and turn it off. Bring my power. Okay. And let's go ahead and give just any one of those. Disconnect this out.
Well, you're gonna need the ground, so.
No, because I want to go across.
You want to go directly up there.
Mm-hmm. Yep.
Okay. Okay.
And that's routed to your power supply. So all we need to do is grab a probe and then go between your probe at the gate and the cathode, and there you have it. And that's a signal that you want to go ahead and go to the next one, Tony. And there you go. That signal right there is telling you that the board is firing the SCRs, and you have to take a look at those four signals. Alright, so this is the end of video 1, and now we're going to show you how to adjust the span and bias in the second video, and on the third video we'll power it or full wave rectifier.